right, College Trig, here's our 6.7 Part 2 notes. So what we're going to be dealing with is now we have uh, angles. Our theta is going to have some kind of adjustment there, either multiplying by something or adding or subtracting or a combination of both. So what we're going to do is we're just going to do a substitution strategy and then solve it out later. So whatever is inside your argument of your trig function, let's just call it x. So we're going to say x is equal to 2 theta. And then we have a new problem that's going to say cosine of x is equal to negative 1/2. Well, we're going to solve this just like we did in the previous lesson. So cosine of x equals negative 1/2. So cosine is going to be down here in quadrants 3 and 4. So cosine is going to be equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So once we get that as our first two solutions, we can write our general solutions out. So then remember, we're still working within our x variable. So x is going to be equal to 2 pi over 3 plus 2 pi k. Then the other solutions for quadrant 3 solutions, we get x is equal to 4 pi over 3 plus 2 pi k. I don't want the solutions for x, so now I'm going to do this resubstitution, and I'm going to say that 2 theta is equal to 2 pi over 3 plus 2 pi k. So pairing up this one and this one. So now I solve this out. So to get theta by itself, I divide this by 2, and I divide both these by 2. By doing so, I get theta is equal to 2 pi over 6 plus pi k. Similar strategy to get the second one. Here, I'm going to say that 2 theta is equal to 4 pi over 3 plus 2 pi k. When I divide everything by 2, I'm going to get my second part of theta. That's going to be equal to 4 pi over 6 plus pi k. So after I have those, I can go ahead and find my first 6 solutions. So I'm going to let k equal 0, 1, and 2. So for switch colors here. So for this problem, when k equals 1, I get 2 pi over 6. And if it helps, I'm going to write this as plus 6 pi over 6. So you get our common denominator. So this is going to be 8 pi over 6. And then add 6 more, and I get 14 pi over 6. I need to reduce these, so I get pi over 3. And I get 4 pi over 3. And I get 7 pi over 3. So those are 3 of my solutions from this angle. Now I'm going to find 3 solutions for this angle. So I get, when k is equal to 0, I get 4 pi over 6. And then I also will get, again, I'm going to do 6 over 6. So then I get 10 pi over 6 when k is 1. And then when k is 2, I'm going to ahead and get 16 pi over 6. I want to reduce, so I get 2 thirds pi, and 5 thirds pi, and I get 8 thirds pi. So my final solutions are here, circled in black. There's 3, and there's 3 being my first 6 solutions. Make sure you realize we can check our answers on here. So if we pull up our calculator, and I want to look here on the calculator, I can type in my equation. So I have cosine of 2 theta, cosine of 2 theta. And I'm just going to type in those answers and make sure that in my table I'm getting a value. I want them equal to -1/2. Okay, so let me change my view here. So I get it over here. So now if I do second table set here, I want to make sure my independent variables on ask and my dependent variables on auto. So now if I go to second table, I can type in those values. So when I type in pi over 3, I get -1/2 for pi over 3, -1/2, 7 pi over 3, and I get -1/2. So I can check my answers that way, which really gives me a vote of confidence when working through these problems. Okay, so let's look at our final example here. So this one's a much more complicated. We have a bigger type value here, but we're going to attack it the same way. We're going to say, all right, x is equal to pi over 2 minus 2 theta. Okay, so then from there, we're just going to do tangent of x is equal to 1. Well, for my quadrants, tangent's going to be equal to 1 in quadrants 1 and 3, and when it is pi over 4 as my reference angle, so this is 5 pi over 4 for that angle. So then I know that the solution for this, and tangent's nice and cotangent's nice because these are exactly a pi away, so I can just rewrite my general solution as x is equal to pi over 4 plus pi k. Well, I'm not trying to solve for x. I want a theta. So I got to resubstitute in my theta, and I'm going to get pi over 2 minus 2 theta, which was my x. So I'll substitute that in, and I have pi over 4 plus pi k. So again, we're going to solve these out. So I'm isolating my theta. So I'm going to peel away my layers. So minus pi over 2 minus pi over 2. Okay, and then I have -2 theta is equal to common denominator. This is minus 2 over 4. So I get negative pi over 4 plus pi k. Then from there, I got to divide by -2. Divide this entire side by -2, and I get theta is equal to pi over 8 minus pi over 2k. So I got to be strategic here and think about this logically. I need my thetas to be positive. So instead of letting k be equal to 1 and 0, 1, and 2, and possibly other larger ones to get all the ones from 0 to 2 pi, I want to make sure I get positive theta. So I'm going to let k be 0, -1, -2, -3, and so on, so that it will take care of that negative sign there, but I'll still get within my intervals. So my first answer is theta is equal to, when k is 0, pi over 8. When k is 1, I'm going to have pi over 8, and now it's going to be plus because I'm using k's, they're integers. I can make them negative if I want to. So pi over 8 plus pi over 2. Well, this is the same thing as pi over 8 plus 4 pi over 8. So I get 5 pi over 8. Okay. Well, for the next one, I just realized that I'm just adding 4 pi over 8 each time. So then I'm going to get 9 pi over 8, which is slightly over pi. So I still have more to go to get all the way to 2 pi. So I keep doing k values until I get values that are larger than 2 pi. So then after this, I get 13 pi over 8. 17 pi over 8. And then I stop and think, all right, 16 pi over 8 would be my 2 pi. So I don't want to go above 16 pi over 8. So 9, 13, 17, this one's too big. So I can stop there. And then I have these as my 4 solutions in a 0 to 2 pi interval. That's our notes for the weekend, and this section 6.7. I'll see you guys next class.